Hey everyone, welcome again. Just wanted to say thanks to everyone that has been supporting the page. And also, I have a tiny favor to ask for you guys. Can you please share this content with students that you might know, especially students that are moving from that high school, then going into college phase, so that they can, help them to know about and learn about different careers. Well, I'm gonna leave it right there. Enjoy the video. Thanks again. Don't forget to like and subscribe. All right, appreciate you guys. Welcome everybody to another Career in Spotlight segment. My name is Sean Gillens. For this platform, we're trying to share different careers that are potentially good options for students out there and for career changers as they consider, different professions, what they might be interested in. Today, our spotlight will be on engineering, and we'll take it from there. So we have our guest today, Chanel Staple. Welcome, Chanel. Pass
Welcome.
it over to
So
you to do
glad.
your introduction. I don't want to, yeah.
That's fine. That's fine. So, hi everybody. Good morning. My name is Chanel Staple, as Sean said, and I am a aerospace engineer. I have been in my profession for roughly the past 12 years or so. I graduated from the University of Florida for my undergrad, where I majored in aerospace engineering. So I knew from I got to college that engineering was the field I was interested in. And I knew that aerospace was where I wanted to go. I went on after I graduated to Georgia Institute of Technology, Georgia Tech, where I studied and did my master's degree also in aerospace engineering because I wanted to gain even more depth than I already had based on me leaving college. After doing that, kind of got into that limbo as to which direction to go, what do I want to do. So I ended up working for the US Air Force as a civilian for a couple of years under an internship program, and it was more systems engineering more than aerospace. And I knew eventually I wanted to get back into the aerospace
Yes, sir.
engineering field. So I ended up getting a job in South Florida at a company named Power Systems Manufacturing, which is where I am currently employed. And I have been there for over the past 8 years,
Okay. Okay.
working with them as a secondary airflow engineer. And this is where I'm at today. And that is, in a nutshell, my career so far within the aerospace field. And I hope that after today's discussion, to those who are not sure about engineering and even more specifically aerospace engineering, hopefully I will give you guys enough information to at least help to coerce you into the great, awesome field of aerospace engineering, and that it is the best engineering field. No offense to the others, but it is. So hopefully we'll have a good discussion today, and thanks for having me.
Oh yeah, without a doubt, man. Welcome, welcome. That you just blew my mind. Just aerospace. All right, we're gonna go into it. First of all, let's take it back to high school. How did you know that engineering was what you wanted to study? You know what I mean? What hit you from early? You got a math bug?
That's a really good question. So here's the thing. So interesting enough, I actually learned that I wanted to become an engineer from the ninth grade. So after I left middle school and I came into high school, I enrolled in this. I saw this intro to engineering course that a teacher had, Dr. Fusillo. Unfortunately, he passed away. Rest in peace to him. But he had a course called Intro to Engineering, and I ended up taking that course. There were 4 levels to it for each year. I ended up taking that course each year, and each year I continued to get exposure to the different engineering disciplines. But I actually got more focused into aerospace engineering per se around the ninth or 10th grade. The first engineering I actually got exposure to was civil engineering. And civil engineering has to do with construction of roads, bridges, highways, and the like. And I actually thought that was interesting too. That was probably one of the areas that I would consider going into as well, because yeah, I do also have a fascination with infrastructure. But then I also learned in the second half of my freshman year, I learned about aeronautical engineering, which is a sub branch of aerospace engineering. And I'll probably explain a little bit more about what aerospace engineering has to deal with, as well as where the aeronautical portion comes in. But I learned about aeronautical engineering. And if anybody knows me, they know I've loved airplanes since I was a kid. Like,
So that's where it comes from.
I've been fascinated with airplanes ever since I was a child. And when I learned that there was an engineering discipline that was solely focused on airplanes and the technologies of airplanes, I was like, that's it. That's where we're going with. So I have been focused on that ever since. And I then learned the following year about aerospace engineering. Now, I was like, oh, they seem kind of similar, but aerospace engineering is basically a much broader topic where it's covering everything that has to do with the air and space. So it's all technologies and vehicles that fly through the air. That's the aeronautical side. And then you have the other side, which is the space aspect. So, you know, the space launches, rockets, you know, space shuttles.
Like NASA.
Right. That's the other side of it. That's more the space focus. So you have the air focus things, which is like the airplanes and the technologies used to fly airplanes, helicopters, gliders, all of that, everything doing with the air on Earth. And then you have the space aspect, which is, of course, the final frontier, where there's no space involved, no air involved. It's all space. You're dealing with rocket propulsion, completely different. Same field, but it's two different aspects.
Two segments of it. Yeah.
Two main segments of the field. And then even within those, you're going to have sub branches of those. You're going to have you know, the aerothermals, like aerodynamic focus. You're going to have structural focus, where you're focusing more on materials and structural integrity. You'll have, you know, combustors, you know, where you're dealing with maybe the combination of the like. So there are a bunch of sublet categories under the entire aerospace umbrella. So yeah, it's quite an interesting field.
Right. Okay, dokies. All right. Making me feel bad already.
I told you, I came prepared. I was ready for you guys. I'm trying to tell you guys, this is the field to be in.
Oh my gosh. All right. So you mentioned civil, and I know that there's so many different branches of engineering. You want to kind of do a quick overview of all of them? I not all of them, because I did a Google search. There's too many, but I think there's like main categories.
Yeah. So I can list a few of them. So I listed civil, which has to do with infrastructure, with roads, bridges, tunnels, that kind of thing. Also very interesting. There's aerospace, which I just touched on, and which we will elaborate more on later. There's also chemical engineering, where it's more focused on chemistry and dealing with, you know, you also have petroleum engineering as well. You have environmental engineering, where you're dealing with things in the environment. There are also a couple others, like nuclear engineering. So you're dealing with, you know, nuclear fission. And all of that. Yep. You also have they have a few others, like marine engineering, coastal engineering, that deal more with maritime, dealing with water technologies and that kind of thing. I keep thinking that there's some other major ones that I'm just not thinking of, but I mean, there's also structural, electrical. There we go. Yeah. Electrical. There's structural, and trying to see if there's any. I mean, there are more, but those are some of the more popular ones.
And it was just a laundry list. Of different types.
Mechanical. I forgot about mechanical. Oh, just to throw in something about mechanical and aerospace, they're actually very close. A lot of times, people who get their aerospace degrees, they often can get the mechanical. That's probably the closest link to having two different engineering degrees. You can have a mechanical engineering degree and an aerospace engineer. That one is pretty close in terms of transferability. Aerospace, they may learn a few more specific classes, and mechanical, they may have their own as well. But a lot of the classes, they're very interchangeable. So people usually get dual degrees in those.
Okay. All right. And then, so what type of, I know you have your bachelor's, you have your master's. Is that a requirement, or is it that you can still, I think you said earlier, you mentioned that you did your master's to kind of, broaden your knowledge. Well,
Mhm.
even deeper, not broaden.
Go deeper.
Yeah,
Right,
go
right.
deeper into
Yeah,
aerospace
yeah.
engineering.
So
So that
that,
should tell me that it's not necessarily a requirement, but you definitely need a bachelor's, right?
yes, you absolutely do need a bachelor's degree. The bachelor's degree, the benefit of that is with the undergrad degree, you get a broad exposure to the different classes that you need to take, the different types of engineering,
Mm-hmm.
as well as just some general knowledge, your calculus, your physics. That is extremely important. As I'll go on and we go into more depth, you'll see that this is
Yeah.
not one of those degrees where the things you learn, especially from the maths and the sciences, that, oh, you learn it one time and you forget it. You find yourself applying and building on a lot of what you
What
learn,
you learned.
and you carry a lot of that stuff depending on the area of focus that you have. You end up carrying a lot of that stuff throughout your entire career, actually. So
Right.
it's important that with engineering in general, you get the basics. So you absolutely need the bachelor's degree. Now, once you have the bachelor's degree and you have an idea as to specifically what you want to do, then you go after your master's degree. Master's degree gives you the depth that you
The
need.
depth that you need.
You can go to the master's. The master's degree, you will definitely get some depth there. If you truly want to be very comfortable in what you're doing and to have a level of expertise where you're able to just say things at whim, go for the PhD, because the PhD with the qualifiers, it forces you to really understand the fundamentals. You're not going to be able to put a thesis together if you don't understand the fundamentals and you don't get through your qualifying exams.
Right.
So I didn't want to go through that process because I know how grueling it can be.
Yeah.
I was satisfied with the master's. The master's gave me the level of depth that I was okay with. And I figured that once I got into the work world and I started, of course, focusing on the work world forces you to focus even more on a particular discipline, because when you're working at a job, more often than not, you're pretty much doing one task most of the time. So I knew that with working in the work world, I would get the depth that I would eventually need to become a subject matter expert. So kind of the goal is to be good at what I do, where people will come to me and ask me questions about this specific subject because I've been working with it for so long.
Right. Okay, yep. Okay. All right. So what type of skills now? Let's go to skills. So what type of skills should students be or not just students, but anybody really be trying to develop, right? And what I mean by that is, say I'm a student pursuing an engineering degree, what should I be paying attention to? In terms of skills that will be making me really setting me up for a good transition into the work world, Right.
Okay, that's a good question. So the first thing is you have to know the fundamentals. You got to know 1 + 1 is 2. And then you start from 1 + 1 is 2, you work your way to 1x + 3 = 4. And then you work through algebra, you work through trig, you work through geometry, and you work up to calculus. You have to understand the actual fundamentals in terms of basic math, basic physics. You do need to understand that.
Right.
But that in itself will only carry you so far. So once you have that understanding, in order to transition to engineering, you have to learn how to use those skills to solve real life problems. That's what engineering is all about. It's solving real life problems. You have an actual problem. You, for instance, want to be able to generate, you want to be able to fly an aircraft using less fuel, making it less noisy, doing all these things.
Right.
These are real world problems, and you have to be able to use those fundamentals that I just discussed and be able to apply them to real life problems. So then once you have the fundamentals, which is great, but then you're going to have to consider, can you manufacture it? What's the cost of manufacturing it? What's the timeline of doing all of that?
Moving variables.
Is it something that's really feasible? Is it something that can be done right now? So you basically go from that's the difference between a math major or a physics major and an engineer, is that they're focused more on the theoretical, doing everything, theoretically, based on books and research and all of that. But then the engineer takes that knowledge and starts to apply it to real life problems. And that's the main difference between the two.
I think I like that. I like that.
Yeah.
Because that's the that's the cornerstone of like how I teach, right? So I don't care too much as it pertains to the theory, because when you can apply something, that means that's showing full understanding of the theory.
Right.
You know what I mean? But you can actually know the theory, but don't know how to apply it. You know? And so that in itself is a skill. I like to
Exactly. So you have to, so it's good to know the fundamentals, but for those who are considering it as a major, you have to develop your problem solving skills. You have to be able to see a problem, realize that you're not going to have everything handed to you. That's the other thing, is that you're most likely going to be lacking information. So there may be times where you'll have to apply assumptions, and you may have to go with guesses until you get more data available. It's all a part of dealing with it in real time. And what you'll end up, the key thing there is just to be clear as to the assumptions you make and what methods you're using, and to make sure that it's applicable, whatever you're doing. So your problem solving skills has to be on point.
Okay. All right, let's switch it now. Let's go to post-college now, right? So what advice, I think you probably even laid on some advice right here for students as it pertains to engineering so far, but what advice could you give them as it pertains to the area that they should probably be studying? So you knew plans for what you're gonna do.
Right.
And so because there's so many different types of engineers, I guess it kind of goes with what happens for the students in terms of what clicks for you. If you like chemistry, then you do chemical engineering, right? Something like that. I think that's probably where we're gonna go with it.
More or less. And actually, but to be honest, you really want to make that decision before you even get to the end of college, because by the time you get to the end of college, you're gonna have your specific degree. So what you really have to do in high school, if you start thinking about it, you're ahead of the game. That's great. But more often than not, most engineers, they figure out which avenue they're going to take within the first 2 years of college. So the first 2 years of college, you're learning the very basics. You're learning the calculus. You're learning the physics. You may take, chemistry, depending on if that's what you want to do. You take your basic circuits courses. You take your, differential equations. These are all things that every engineer would want to at least have in their back pocket, or at least to have some level of exposure to. Right. And once you learn these courses, in the meantime, what they need to be doing is they need to be looking at the different types of things out there and considering their interests. I highly encourage, for those who are looking in the engineering field, look at what interests you. What interests you as a person? If you find yourself loving airplanes like I do, aerospace engineering might be the way you want to go. If you find yourself being fascinated with seeing highways, roads, and bridges, and you want to know how those are constructed, how do these bridges span for miles and miles and miles and hold up for decades, even centuries in some cases. How do they do that? What is exactly done to allow for it to withstand weather conditions and the test of time? You may want to go into civil engineering. If you find that, you're fascinated with nuclear related things, if you want to potentially help design a nuclear submarine someday, you might want to go into nuclear engineering. So you start thinking about that your first 2 years, because your third and your fourth year, by that point, you have to start picking classes that pertain to your line of engineer, which is why, based on one of the questions you had, you can't hop from engineer to engineer to engineer. It's not that simple, because you start learning very specific skills that pertain to your line of engineering. You will always know the basics, but in order for you to go to a different engineering, you have to take those courses and get that exposure. And you want to know that before your third year. So by the time you get into your third year, you should start to focus. So once you've done that, then when you graduate, the other thing that you should be doing, and I kind of fell into this trap. Well, not intentionally,
Mm-hmm.
but it's something that it was a difficulty that I had to work around. If you can get internships early, do so. If you can find yourself your freshman, your sophomore year getting into an internship at a company, definitely do that, because it helps a lot once you graduate in order for you to get your first job.
Right.
I found it very difficult to even, and the thing is that it's difficult to even get internships because it's so competitive. So it's a vicious cycle. You're trying to get an internship, you can't get in, and you get to the end of your college career, and people have internships, you don't have any, so you're already kind of at the bottom of the pack in terms of landing that first job. But the way to potentially get around that is do research. If you find a professor or a class that interests you and you really like the class, or if you just like the professor, talk to them afterwards. Meet up with them and say, hey, I want to get into some research. I like what you're doing. I want to hear more about what you're doing. Get into some research. That takes a lot of the pressure off in terms of getting the internship, but it puts you still at the top of the pack, because they will see that, oh, you did research in this, this, and this. And it doesn't require nearly as much pressure. And the thing is that you could do this for free if you want. There's some who do pay, but if you just say, hey, I don't care about getting paid, I just want the experience. I'll work for a couple hours, a few hours each week, maybe 10 hours each week. I'll come in and help with your research just to get that exposure. Yeah. Do one or the other. At least get the internship, but if you can't get the internship, definitely get the research, because that will make you a more I say a riper fruit to be picked.
Yeah, basically.
When you're about to get into your first career, your first job, you want to be that ripe fruit that is just perfect for picking.
Right. You're making your resume very much attractive for employers.
Yes.
And because it's the same thing in the actuarial space also. They love to see internship experiences. But as you said, I like the fact that there's alternatives also. Doing research is also another option for students, because I can imagine, it's probably very competitive. You have to really, and for any student that's watching this, that kind of implies your grades got to kind of stick out also. You know what I mean? If you want to be the ripe apple for the picking, Right.
And I will say this: if your grades aren't exactly up, because I don't want there to be this huge emphasis on grades either.
Right.
It's important to have the grades, yes, but you also don't. Whether it's an A or a B, in the grand scheme of things, it really doesn't matter. Right. The key that matters is the experience you've had, and that whoever you've done work with can say good things about you. If you have those things, even if the grades aren't a perfect 4.0, even if it's a 3.5 or even a 3, if your experience is solid and whoever was employing you for that experience can speak good things about you, you're in a great position to go into your career.
I like that. All right. So let me see what next. You kind of handled the other question too, as it pertains to transferability, because that was one thing that I thought about. I was just like, well, if I started off saying I wanted to be a chemical, and I don't want to be this no more, I wanted to change to something, how can I do that? And you kind of, I think, touched on it basically to say, well, you kind of have to make sure you do a reflective state, early, to figure out what area is really your peak interest, or where you really want to see yourself, right?
Right.
But you did highlight, though, that there probably the the best transition that you can probably do is if you start off like aerospace or mechanical, that kind of might transfer a little bit.
Yes. So in the case of aerospace, it's easy. It's a bit easier to do. To maybe add a few more classes and also get your mechanical engineering degree. So if I wanted to, I could probably apply for a mechanical engineering job as well, even though I have an aerospace engineering degree, because a lot of the courses, they're pretty similar. But if I wanted to, for instance, do a civil engineering job, unless I already had experience doing a civil engineering job, it would probably be difficult for me to be able to make that switch. So I guess I would throw that in there is if you do want to do a switch, you would have to have experience within that field because experience also helps to replace any potential education requirement that you may have. If you already have a degree and you want to switch to a different type of engineering, make sure you have the experience in that field to back it up.
Got it. All right. So let's jump into the work world. All right. So walk us through, man, a typical day. Typical day.
All right. So as far as this goes, I think I want to use this as an opportunity to kind of show you. I'm going to share my screen. I'm going to show you.
Yeah, let's do it.
Show you what I work on.
Got my coffee ready.
I do. Yeah. So, show you some of the stuff that I work on, and I'll try and give as top level of an explanation as possible, and then I'll show you where I come in terms of what I do. So let me share my. Oh, you disabled participant.
Oh, my bad. I had to do something.
Yeah.
There we go.
Okay. Yeah. All right. So let me share my screen. All right. Can you see that?
It's loading. There. Okay. We're seeing some stuff.
Some stuff. I'm gonna do my best to explain to you what exactly this stuff is. So what we're looking at is what I typically work on a day-to-day basis. This is a land-based gas turbine, and the whole purpose of this is to use air to create power. That's
okay.
So the power that your equipment and my laptop, if it was connected to the wall, any light that I'm using, there is some gas turbine located at some power plant that is being used to generate the power, right?
Got you.
So yeah, so I'm gonna walk you guys through as top level as possible what a gas turbine does and how it generates power. So what we're looking at here is a cross section. This is a cross section of a gas turbine. This is the lower portion of it, and this part is showing it covered. So when if you're just standing up on the outside of it, looking at it, this is the kind of stuff that you would see. But this is the cross section. So you just take a knife and just slice it down the middle. So that's what we're looking at here. So what's happening is we are taking in air. So it's all based on air and fuel. So we're bringing in air through here, and then what's happening is it's going through what's called a compressor. So you're taking the air and you're compressing it, and when you compress air, you're increasing its pressure. Right. So by the time it gets down to here, you are looking at air pressure that could be over 200 psi. So so you think of a square. So this is roughly a square inch. Right here, a square inch of air. Think of that, a grown man focusing all his weight, say he's 200 pounds, focusing all his weight on this small amount of space.
Got it. Right.
That's a lot of pressure. A lot of pressure. So you're focusing, you're creating this high pressure air, and you bring it into the shell area. And then what you want to do is you want to combust it. You combine it with fuel, and you also have an igniter. So you have a burner here, and that high pressure air is being injected into here with the igniter as well as with fuel. So when that happens, you get a combustion, big boom, right? So it's of course controlled. So what happens is the air now and the fuel that's coming out of here, down here, it was roughly around 700 degrees Fahrenheit or something like that. Still pretty hot. When it's coming out of here, it's well over 2,000 degrees Fahrenheit, right? So it's some hot stuff, like melting metal hot stuff, right? So then what happens is down here, this is where I guess all the magic happens. So this is called your turbine. So you have your compressor here that compresses air. You have your combustor, which is where you combust the air and the fuel, you combine it together and you ignite it. And then down here is what you have a turbine. Your turbine is where you extract your power from. It's where you extract your work. So what happens is you have these vanes, which are stationary, and then you have these blades that are rotating. The rotating blades extracts the work from the hot fuel, right? From the combusted air and the fuel, from the hot, we call it hot air, the hot air. So from the hot air, it extracts work, and that extracted work is used to drive the compressor, and it's also connected down here to a generator. And that generator is what's used to generate the power that, you know, is used to power our homes. So that at a very top level is what a gas turbine is about. But then we have a dilemma. The dilemma is, as I said, this air that's coming out of here is over 2,000 degrees Fahrenheit, which is enough to melt metal, right? It's very hot. It's significantly hot. And yet we have these parts in here that are getting exposed to it. So how exactly is it that these parts are getting exposed to this hot air and not melting?
That was actually what popped in my mind. I was waiting until you, I was just
I'm glad you said that, because that's where
material are these things made out of?
Right. So even with the materials that they're made out of, these are different metal composites, and they're able to manage, you know, high temperatures, you know, 1,000 degrees or so before they melt. But the problem is that it's still too hot. So where I come in is what's called secondary air, and secondary air is actually the system down here where cooling air, it's air from the compressor, is taken off, and it's used to flow through these different components to keep them cool. So by keeping them cool, by extracting heat that it would be exposed to, it keeps these components a lot cooler than if you didn't pass any air through it. It's kind of like drinking. It's like drinking water. You know, like when you're really hot and you drink water, and then all of a sudden you feel cooler. Yeah. Because your body feels cooler. So basically the cold water is taking heat away from your body and makes you feel cooler. That's exactly what's happening here. So we have secondary airflow. We have this air, which is what I work with. That's what I do on a day-to-day basis. I need to make sure that I am tracking how much air is being used by each of these components, so that because it's a delicate balance. I have to make sure that I provide enough air to each of the rotors and blades in the gas turbine so that they don't burn up. But I also can't take too much, because if I take too much, then there won't be enough to go through and go into the combustor to create power. It's going to take away my power.
Balancing act.
Exactly.
Balancing act, right? Yeah.
Exactly. So day to day, what I do, I have models that basically represent the air that would be flowing through this system. We call it the secondary airflow system. And what will happen is I need to make sure that I am bookkeeping and keeping track of any type of changes to this air, anything that would change in terms of the requirements of these parts. I need to make sure that I provide the air that these parts need, so that when they're put in the engine, they don't burn up.
Right.
That's my job. So yeah, so it's really interesting. It's really interesting stuff. I look at it as, it's like a puzzle that I work with every day, where I am making sure that, you know, the air that's being pulled off is enough to, you know, keep these parts cool, but not so much that it's taken away from the power.
Exactly. Because I would think that another variable you have to worry about also, which is kind of correlated with how much is going to the combustion portion of this, is how much electricity is being produced.
So
at the end of it. So I can see it's a assessment on, you know, on balancing all of these moving.
All of these, right. So there are other things that are going on as well. You know, there's a generator that we don't necessarily keep track of. We solely focus on the gas turbine. Right. And for us, our goal is to make sure that we're providing enough power, which is usually measured in megawatts. So we need to make sure that the megawatts that these engines are supposed to be producing, that they're producing that. If they're not, then it's our responsibility to find out why. Because we have customers that we have to support, and if we're not meeting our key thing is supporting what the customers want, and the customers are these different sites that have these gas turbines that we help them maintain, we help them to, you know, bookkeep and make sure that everything is in working order. So So yeah, that's a day. And what my job is working with these things and making sure that these parts are getting the air levels that they need.
Got it, got it, got it. I like this, man.
Yeah.
It actually just hits home a lot of similarities with these professions, man, as I'm learning more.
Yeah.
From the standpoint that, you know, I'm not even going hard on this point too long, but I'm just noticing it's just assessment on moving variables and using the math knowledge and all of that groundwork
Yep.
to make sure that you're solving real life business problems. You know, I'm
Yep.
solving
Exactly.
insurance problems, you're solving you're solving more
More technical,
more
but
real life, like
it's still a
civil,
real
like I
life
said, it's like
problem.
everywhere, roads and all these problems that are being handled by them, you know.
Yeah.
So that's good. I like that though. I like that. Yeah.
Yeah, man. So yeah, I wanted to at least share with you guys what, because a lot of people don't get the insight as to how these gas turbines work. And the thing is too is that what I showed was a land-based gas turbine, but it's the
Mm-hmm.
same exact technology that is used in airplane engines. So airplane engines that we fly on, this is those turbojet engines.
Yeah.
That's the technology they use. It's just to a much smaller scale, and
Right.
they have different requirements. They have more stringent requirements because, of course,
Mm-hmm.
you're dealing with the lives of passengers and all of that. So there are
Regulatory.
far more stringent safety requirements that they
Right.
would have to meet, but it's the same exact technology.
Got it. Got it. Got it. Got it. Got it.
Yep.
Got it. Got it. I like it. I like it. I like it.
Yep.
All right.
I told
Okay.
you. I told you. I was coming to convince you guys, letting you guys know that this aerospace engineering is the way to go.
Got you. Got you. All right. What about, all right, since we're in work life, what about work life balance? How's that been for you in your experience?
So work-life balance, this answer really depends on the person. And I'm glad that it was a question you asked, because at the end of the day, there's some careers and there are even some aspects of um, aerospace engineering, depending on the area that you go into, where
Mm-hmm.
your work-life balance, it may be kind of thrown for a loop. Like, for instance, if you're working in a lot of flight test stuff, or if you're working on, for instance, in my company, if you're working in service engineering, where you're keeping track of outages that may be happening, outages at different engine sites, they're happening 24 hours a day,
Yeah.
rotating
Right.
shifts. So depending on what's going on, your support may be required at odd hours. But
Got
I
you.
think at the end of the day, the work-life balance all comes down to you as an individual. It's extremely important that you understand what your level of commitment is to your job,
Mm-hmm.
how much you're willing to give, and how much you're willing to say, hey, okay, this is becoming too much. I need to focus my energy on my family, or my
Right.
hobbies, and balancing the other things in your life. That's extremely important, because and the thing is too is that, Sean, so
Mm-hmm.
many people, um different people have different tolerance levels, right? There's some people who are workaholics, and they'll put in 60, 70, 80 hours, and they absolutely love it, and
Yeah.
that
Yeah.
works for
Yeah.
them. And then there's some people who they want to put in their 40 and they're done, and they don't
And
want to
peace
put in an
out.
hour,
Yeah.
and they don't want to put in a bit more. To
Right.
me, what I would tell them is, find out where exactly you fall on that spectrum based
Yeah.
on what you do. And once you find out where you fall on that spectrum, draw that line in the sand as to what level you're willing to go up to, and don't go past that. Because
Got it.
once you start going past that, you're going to start resenting your job, because it's taking away from the other things that you may want to do. So my answer to you is, it really depends on the person. And the
Mm-hmm.
key to those who are concerned about work-life balance is to know what your tolerance is, know what you're willing to work, whether it's
Right.
40 hours, whether it's 100 hours, whatever it is you're willing to do that, and do that
Mm.
to the best of your ability. But make sure you draw the line and focus on the other things in your life that are important to you. It's extremely important, because I've seen too many people get burnt out, get overwhelmed, and get really stressed out, and they just start resenting not just their job, but they start resenting life in general. And
You're preaching right now. You are
and as
preaching right
much
now.
as much as I enjoy my job, I
Yeah.
cannot allow for it to get me to the point where I start resenting my life. So I make sure to keep that balance. I put in my time, I put in my 40 hours, but after that, when I am home, I do things at home that I want to do. I spend time with my wife. I also spend time with myself doing the things that I enjoy. So find what works for you and stick with it and draw that line in the sand. That's what my answer would be to that.
Perfect. I love that response. It will probably be my response going forward. All right, let's close it out. Really, any final advice for interested students? I know you've been selling it really hard this whole interview. Close us out basically with any final remarks for students, that are potentially interested.
For students, I would say do your research early. If you are interested in it, take a look into things early. Don't necessarily overwhelm yourself. Enjoy your life, but take a look early. Look into things. Ask questions. Do your research. It's extremely important to do your research. And another thing to throw in there, we talk about work-life balance. Find out ideally where you want to live. Find out if you're the type who, do you want to live in a particular region of the country? Do you not care where you live? Do you want to be able to travel? Whatever it is you want to do, figure out what type of person you are and see how your career fits with that. Don't try and fit your career. Let your career fit you, fit your style, fit who you are. So yes, take it seriously, do what you have to do, keep those grades up. And for those who are trying to get into college, try and get scholarships. Please get scholarships. Don't take on loans. Try and avoid loans as much as possible, because there's so many people, and I'm not just talking engineers, but general people who have worked through college, they are lamenting the fact that they took on so many loans and have to pay that back later. You don't want that in your life. The key here is with high school, do your studies well, get those high grades, stand out so that you can get scholarships. Get as many scholarships as you can, apply to financial aid, ease the burden of the financial cost of a college education as much as possible. Do that and you will be so far ahead of the game. One of the fortunate things that worked out for me was that I was able to get a full ride both at University of Florida and at Georgia Tech.
Okay, awesome.
Thanks be to God for that, because it saved me a lot of the headache of having to repay student loans. I don't care how great your career is, you do not want a debt monkey on your back. So focus on your studies, but at the same time, enjoy your life. Don't be too much in a rush. Do the preparations, but balance your life. Figure out what works for you, and just be the best you can be. And don't beat yourself too much up about it.
I love it. So with that, thank you for you were preaching today. You were doing a lot of fun to get on, and as you said, you really came ready for this interview. I appreciate you. So thank you once again, Chanel. And for everyone, stay locked for another career. We're going to be spotlighting in the next episode, next segment. All right. Bye-bye.
Thank you, guys. Thanks for having me. Take care.